Hello everyone, welcome to my channel. So in this video, we will continue introduce the materials in our actuarial math and also the financial math. So in our last lecture, we already introduced more information about the interest rate. In this lecture, I want to start to introduce what is a simple interest or simple interest rate. Okay, so in last lecture, we already know if we can compounding our interest, which means it's kind of at the end of each compounding period, we will reinvestment the interest we earned into the investment again. And we also have the growth the notations about how we can compute the accumulation after a t period of the compounding period. So we know the growth, compound interest growth, generally we denote this by small at, which is this one. And then we can use this notation to help us compute the gross amount of our investment, which is denoted by the initial investment amount times the compound interest growth. So this is one way about we will reinvest the interest we earned by the end of each period. However, if we didn't reinvestment this interest, this is simple interest. So the difference between compounding interest and simple interest is at the end of each period, do we reinvestment this interest we earned? So here, of course, this compounding period, it can be annually. So it's like every 1 year we compute this interest we earned, or it can be like every month, every quarters, or even every day. So for the simple interest, is also first we fix interest period. For example, annual simple interest rate, or say the monthly simple interest rate. And then for the simple interest, we also call simple interest as yield. So in future, if you say our yield of a bond, that means for this bond, we use the simple interest. So in future, when we talk about bonds, you can get more information. But simple interest rate, actually it's really common to use this one when we talk about some shorter period investment, or say shorter period saving. So we use simple interest much more. Okay, then for simple interest, we will also have some notations for our simple interest. For the compounding interest, we know we use a small at to show the growth of our, or say the compound interest growth after t period. Then for the simple interest, we will also use this notation, one notation to help us show this. So here we still use A, but we say this is a bar. There is a bar above our A. So here this A bar T, this is our simple interest growth after T unit of time. So here if we say this period is 1 year, T means T year. And if this is a month, then this means t months. For here, t generally is only be some positive number. So for example, 1, 2, 3, some number like this. They never be some negative number, and in general, this only be the integer number. Okay, so then we want to know, okay, what is the formula for this simple interest growth? So in the compounding interest growth, we know this is 1 plus I to power t. And also in our previous video, we explain why the compounding interest growth is look like this. So if you haven't looked at the video about our compounding period and the annual effective interest rate, so I I strongly recommend you to click the link for that one. And for simple interest, the notation actually is much simpler compared to the compounding one. So here we will have our AT is equal 1 plus I times T. So here I is our interest rate, simple interest rate for each unit of time, or say each period. So this is what we have for this simple interest growth. Okay, so now first let me use a little more sentence to explain why we can have this simple interest growth look like this. So if we want to know this, assume initially we will have only $1 to investment. So that means in time 0, our initial investment amount A0 is equal 1. So in our account there is only $1. Then at the end of the first year, for example, we say we period as year, 1 year. Then at the end of the first year, the A1, which is the amount in our account, should be the initial investment amount 1 plus the interest we should earn by this period. So because the interest rate is I, so that means this is 1, which is our A0 plus our A0 times the interest rate, right? So that means here, if we plug in A0 equal 1 and plug in the I as our notation, so this is 1 plus 1 times I. So in other words, this is 1 plus I. Okay, so this is what we have. And then at the end of the second year, for example, T equal 2, what we will have? We will have A2. And please remember now in our account, how much money we still keep to earn the interest. It's not 1 plus I, it's only $1, because we say the interest we earned won't be reinvestment into this account. So in the account, we still have $1. And so in other words, you can see the account's value is still A0. And then this A0, let me see. So the money we have A1 plus the A0 times our I. Okay, so A1 is what we have from the previous time, T equal 1. And then now if we count about the interest, this is use our initial investment amount, A0. So that's why here we will have 1 plus I, which is the value of our A1, plus A0 equal 1 and times I. So in other words, this is 1 plus I, so it's equal 1 plus 2I. Okay? Or you can see this is I times 2. So if we do this again, you can find the interest we can earn for each year is always I. It's not increasing because we only earn this interest by our initial investment amount $1. They don't have any more investment or money in our account. So that means here, if we have a general or at time T, so what we will have, our AT, this will have first about our initial investment and also about the interest we earned. For each year, we will earn $I. So for T years, in total, we will have I times $T. So that's why we will have the final, or say the amount here in our account will be 1 plus I times T. Okay, so that's why in our previous page, we say for the simple interest growth, A bar, this is equal 1 plus I times T. Okay, because we didn't reinvestment the interest we earned into the account to earn more interest here. Okay, hopefully this is explain this formula very clear. So then we already learned what is a compounding interest denoted by the AT, the growth, And also we learned what is our simple interest, and the growth is denoted by a bar. So then the question is, if in this case, what the relationship between this, which one will give us more interest by after maybe half year or half period or 1 period or t period. So if we want to understand this, let me use a graph to explain this. So let's we look at this picture together. So here, this is for the horizontal axis. This is about our time, so time t. And then about the vertical axis, this is about our money. So this is how much money we can have in our account. Then so we can see here the horizontal axis is our time and the vertical axis is the growth of the investment. So assume both of this investment is start from $1, and we can see after one unit of the time, no matter you say 1 year or 1 month, then for both a simple interest rate and also the compound interest rate, the value is all increased to 1 plus I dollars. So here I is just the value of our interest rate. However, if we look at this blue curve, this is our compound interest rate. So we can find the growth is not a straight line, but it's an exponential curve here. So in other words, we can find if the time is a short period, for example, smaller than 1 unit of the period, then the simple interest will have a faster increase or growth of our investment. However, after the 1 unit of the period, the compound interest rate will exceed our simple interest rate growth. So here the black straight line, which is denoted by the A bar, is our simple interest growth. Okay, so now by this graph, we can have a more straightforward idea about what's the difference between these two interest rate, compound interest rate and also simple interest rate. And also that's why we said if we invest the no matter in any product, in general, people will use the simple interest rate for the shorter period. That is because it's more straightforward for the simple interest rate, and also this will give us a more clear and also faster growth of the investment. Okay, so we already introduced both important interest rate, compound interest rate, and also simple interest rate. And one more thing I want to talk about in this video is now we have the interest rate, and then how we can compute the accumulated amount. So that means if we denote the initial investment as A0 and we use I to denote the interest rate, we know for A or A bar, this is our interest rate growth or say interest growth. So A is our compound interest growth, A bar is our simple interest growth. Then based on this notation, we can compute our accumulated amount function, which is a function can give us how to compute our investment at any random time t, so denoted by at. So here if we use the compound interest, then the accumulated amount function is denoted by our initial investment A0 times the compound interest growth at, small at. So in other words, it will give us the T, which is our accumulated amount at time t of our investment, is equal to the initial investment times the interest growth. For the compound interest rate, this is 1 plus I to power t. So here t is how many units we will keep of this investment in our account. Then based on this accumulated amount function, what we can know? We know now if we look at the equation AT is equal A0 times this compound interest growth, then we know here we will have in total 4 characters in this, or say 4 parameters in this equation. One is AT, the other is our A0, and the third is our I, and the last is our time t. Okay, so for this equation in math, we know if we given 3 of these parameters or 4 parameters, then we can solving for the last unknown parameter. So based on this, by some mathematical calculation, we can get the equation from this accumulated amount function to compute the other unknown parameter. So now I will skip the details about how we use our mathematics and our knowledge in algebra to get the equation. If anyone interested in this topic, you can just leave a comment under this video, and maybe we'll post a additional video about how we compute this. So here I just directly give you the equation to compute our A0 or I or T. So here, if we don't know the A0, then we can find A0 is equal our AT divided by the compound interest growth. And if I, the compound interest rate, is unknown parameters, then we can use the factor between the AT and A0 to power 1 over T and minus 1. And then to compute the period of time, then we can use the log with base 1 plus I of our AT divided by A0. Okay, so this is what's the accumulated amount function for the compound interest rate. And of course, besides this compound interest rate, we also have the equation for our simple interest rate. So for the simple interest rate, the idea is still same. It still says the amount, investment amount at any random time t should equal the initial investment amount times the interest growth. The only difference is for the simple interest, we will plug in the simple interest growth to here. So that's why in the equation, instead of use AT, here we use A bar T. And also because the A bar T is a simple interest growth for T years, or say T period, then the equation is 1 plus I times T instead of 1 plus I to power T. Okay, so this is our accumulated amount function for the simple interest. And similarly, this is still an equation with 4 parameters. The initial investment amount A0, the terminal investment amount AT, the interest rate I, and also the time, how many period we will invest here is time t. So of course, given 3 of them, we can solving the other one. So here again, I also won't show the details about how we use our knowledge in algebra to compute this. If anyone interested in this, please leave a comment under this videos. So here I will directly give you the equation of how we can solving the other unknown parameters by our accumulated amount function. So we have the initial amount is equal the terminal amount AT divided by the sum between A1 and I times T. And then for the simple interest rate, this is equal AT divided by A0 minus 1, then the whole thing divided by T. And for the time t, this is numerator is still same with the formula of our I. The only thing is now we divided by I instead of t for the formula to get our time t. Okay, so in this video, we already learned what is a simple interest, which is really important interest rate, especially later we will start to introduce the bond, which is always, in general, always use the simple interest. And also we compare between the simple interest and also compound interest. And one more thing is we give the formula for how to compute the accumulated amount function. So here, accumulated amount function, sometimes we also call this as future amount. So it's like accumulated after time passed, the investment is accumulated to other amount, that we can also say, okay, this is the value of our investment after several years or so in future. So we can also call this as a future value. So in next video, we will start to introduce the present value and future value, which is also really important terminologies in this financial math or say accurate math. So thank you for your attention for this video. Please subscribe my channel and leave a thumb up or comments for my videos. So see you in next video.